Okay, there were a couple of homework questions. This is old homework. This is homogeneous and linear. I think this was due a little while ago. About questions 10 and 11. So let's just do one. So y double prime plus 6y prime plus 34y, I think it was, equals 0. And then our initial conditions are -2 and -4. That's an ugly -4. There we go. Excuse me. I'm sorry. I'm still sick. Okay, so just like with all of these, we assume y has the form of e to some lambda t. Then y prime is lambda e to the lambda t. Y double prime is lambda squared e to the lambda t. It's a lambda. So we plug all three of these into the dE. 6 times this one. And then 34 times the original. Supposed to equal 0. We can divide out the e to the lambda t because it never equals 0. So we're allowed to divide by it and we get our characteristic polynomial. On a test, I am okay with you going from here to here. It's perfectly fine. You don't have to write this because hopefully you're to the point that you can just go straight from there to there. You got to be careful though. If either of these guys are missing, you got to be careful and make sure you match your powers up. Remember, the power on lambda corresponds to the order of the derivative. And this is 0th order here. That's why there's no lambda on the 34. So like if I take this guy out and we only had a y double prime and a y, it's very common for people to want to put a lambda on this last one when it doesn't go there. So you got to be careful. Okay, we're going to need quadratic formula for this. So lambda is opposite of b plus or minus square root of b squared minus 4 times a times c all over twice a. And I don't know what it is. I'm just going to type it in here. So 36 minus 4 times 34, -100. These are usually picked so that you get perfect squares underneath there, but not always. So that's -6 plus or minus 10i over 2. And we got to split that up, split up that 2. So -3 plus or minus 5i. So we got solutions of the form a plus or minus bi. So a is -3 and b is 5. We got complex solutions. Then my general solution will be c1 e to the a t cosine of bt plus c2 e to the at sine of bt. So we don't use like a plus or this plus or minus plays no role whatsoever. We're not going to do any kind of plus or minus stuff. We just figure out who the a is and who the b is. There's our general solution. Now that I've got that, I can plug in my initial conditions to find my particular solution. So y of 0, e to the 0 is just 1. Cosine of 0 is 1. Sine of 0 is 0. So let's see, y of 0, that's all going to be 0. That's just going to be 1. I think we just get c1. And that was supposed to be -2. I got the solution right here. Yeah, -2. Look at that. Now we got to do some work though. Y prime of 0. Well, let's find y prime of t first. And I don't know if you guys want to sit and watch me go through all this, but I'm going to have to do some product rules on here. So this would be C1 derivative of the first. Leave the second alone. Plus leave the first alone. Derivative derivative of the second, derivative of cosine of 5t would be 5 sine of 5t, and we pick up a negative. I'm going to put that out front there. And then same for the second, we're going to get a negative 3c2 e to the negative 3t sine of 5t plus, leave the first alone, derivative of the second will be 5 cosine of 5t. And then, like, again, I don't know if you want to watch me go through all the algebra. If you plug all the 0 in here, let's see, all the signs are going to disappear. Cosine just equals 1. E just equals 1. So I think we get negative 3c1 plus 5 C2, and that's supposed to equal negative 4. I'm going through this really quickly just to show you the process. Hopefully I haven't made any arithmetic mistakes here. We got C1 equals negative 2, so that'd be 6 plus 5C2 equals negative 4. So 5C2 equals negative 10, and C2 equals negative 2. I got it right. And say my day here. There's the solution.